Let's now explore in more detail all the scenarios enabled in the front end and how its different React components are interacting with the catalog and inventory microservices. So I have stopped all the web servers at this point, both for microservices and for the front end. They're all stopped because I want to restart them in debug mode. That way we can jump from client to server and see line by line what's going on. So here I am in the catalog microservice codebase, and I'm just going to go ahead and hit F5 to start that web server, and then I'll go to the inventory microservice code instance, and I'll do the same thing, F5. Okay, and now I'll go to our front end, and in this case, instead of typing npm start from the terminal, I'll take advantage of the debug configuration that we have set here. So I'll go to the run and debug section on the activity pane there. And as you can see, we have a few options here. We can debug either server, client, or server client. Server client is the one that I'm actually going to pick so that both the client and the server are started at the same time. So I'll click there. And this is going to bring up the browser right away. However, it may take a while to load while the server is compiling the source code and starting the Node.js server. If we head back here, you can see that the server is getting started, but it may take a while to start. Okay, so as you can see, the server has compiled the source code properly, and it has started a debugging session of the front end in localhost 3000. So now we can go back to the browser, and here we can go ahead and navigate into the catalog section. So I just click there, and then things are loading properly. But how is this communication from the client happening to the server side? So to understand that, what we can do is just head back to play the front end. And what I'll do is I'll open my Explorer on the left side, and I'll collapse the terminal for a moment. And then I'll go into src, components, catalog.js. I'll collapse that. So here, the communication happens in this populate items method over there. First, we call the fetch function, where we talk to the URL of the catalog items API. So I'll talk to the catalog microservice, and then we get a response back from it. The response will tell us the status code if we wanted to inspect that. But this is actually a promise in the JavaScript land. Is called a promise, which means that we will have to invoke the JSON method to actually get the items in this other .10 that we can then take and then put into what we call the state of this page, and then that state is going to later be used into the in the render items table. The items are going to be taken from the state into this method, are received as items, and then we will just render them in a normal HTML table. So let me put a few breakpoints back into populate items so that we can see things as they go. So I'll place these breakpoints over there. And let's also go to the catalog microservice so that we can put a breakpoint on the server side. So I'll collapse this, and I'll go to items controller, collapse that. And then here we can go into the get async method, put a breakpoint there. So now let's go back to the browser and let's just refresh this page. And sure enough, here back into the front end, we have hit the breakpoint. And as you can see, here's where we have the location of the catalog microservice in the items API. So if I say continue, that's going to talk immediately to the catalog microservice. As you can see, now we are in the catalog microservice. Let me collapse this a bit. And here's where we're going to go ahead and talk to our repository to talk to the MongoDB database and then return the items. So I'll just say continue. And now we are back into the front end, where we have received that response, which we can briefly inspect on the left side. Let me collapse this and that and that. And as you can see, we got a 200 status code, which is great. And then we need to convert that promise into the actual set of items. So for that, I'll just hit continue. And now we have our list of items over here in this returned items variable, where you can see we have collected the items from the server side with the date, the description, the ID, and the name as an array. And then if you just hit continue, then we go back to the browser, we can see that the items are right there. Now, how about creating a brand new item? So let's go ahead and click the add button here. And this is the form where you can go ahead and actually create an item. So again, how is this form working? So going back to the front end, go to the code base, you're going to find the code for that under form, in item form, right here. If we go back up, there's a method called create item. So this is the one that's going to be in charge of sending the post request to the catalog microservice to create the item. And we can do the same exercise by just placing a breakpoint over here, and then we're going to get a response over there. Same way, we can go back to the catalog microservice, and we can place a breakpoint into the post async method over here. Now back to the browser, let's go ahead and create an item. So let's say we're going to create, in this case, a shield, and let's call it actually bronze shield. And this is going to be a basic shield. Now, what happens if I just don't put a price here? So I'll go ahead and hit save, and you can see that this is going to happen. So we have enabled client-side validation via React into the client side. So here it is making sure that I have a name and that I have a price. If I don't have a price, then this happens. So sure enough, I can put a price and that should work. But before we do that, what happens if I do something a bit different, like putting an invalid price, like a -5? If you remember, the catalog microservice has been configured with validations, and it should not allow a negative price here. I have intentionally not enabled client-side validation for a negative number here, so that it just let it go. But how would that look like in the over here when the validation actually comes from the server side? To figure that out, I'll actually go back to the front end, and I'll put yet another breakpoint into the catch section over here. So now let's go back to the browser and try to save that. So now we are back into front end. So as you can see, we will send a request to the catalog items microservice. I'll hit continue, and as you can see, we already got a response here. We didn't even get to reach the controller on the microservice because the ASP.NET Core validation runtime verified that this is not an allowed thing. Like the DTO that we sent did not pass the validations. So as you can see, the response here is already telling us that this is a 400 bad request because we have sent an invalid value. And in fact, if we want to know more about what happened here, what we can do is just, let me put another breakpoint over here, and I'll hit continue. And now we can inspect this error data section here. And it says here, yeah, one or more validation errors occur, which by the way is the exact same validation that we were seeing before in Postman for this kind of invalid inputs. And if we expand the error section here, you can see that we have all the errors that are coming back from the microservice, like the field price must be between 0 and 1,000. So this is one way that if you wanted to, you can show that error with that specific error into the client. In our case, we are only showing the error data, that title property. That's as much information we want to show to the client at this point. So I'll just say continue. Then we reach the catch section, which will catch all the errors either from validations or for any other kind of communication errors from the client and the server. And that's going to show an alert. We say continue, and then back to the client. This is what we're going to see. Could not add the item, one or more validation errors occurred. So to fix this, let's actually put a correct price. Let's say 6. Then I'll hit save. So back to front end, we'll send the fetch request. And now we hit the catalog microservice because the validation succeeded. So the controller is actually being hit now. So this will go ahead and, as you know, it will execute the logic to create the item and then publish that item into the message broker in RabbitMQ so that the other microservices can get notice of this. So I'll hit continue. Then we're back into the front end. And this time, if we expand the response, we can see that we got the expected 201. And then we hit continue, and back into the browser, the item has been created. bronze shield, basic shield with price 6. Okay, so what about editing an existing item? So to edit an item, all you have to do is click on the edit button here, and this will allow you to perform the edit. But before actually going through the edit scenario, let me actually just go ahead and remove all these breakpoints, since I think we get the idea now of how communication is flowing across places. So let me go to the breakpoints and just remove all of them over here, and also in the catalog microservice. So I'm going to go ahead and remove all breakpoints. Okay, so now back to the front end. The edit logic is happening if we go back into in item form. So that is happening in the update adding method. So here's where again we call the fetch method with the URL of the REST API plus the ID of the current item. So that will go ahead, do the fetch operation, and then later we'll get a response over here. So let's see how that works in real life. Over here, I'm going to just bump the price from 6 to 8, and then I'll just hit save, and the edit has been performed. Notice how things never reload here, like the page is never really reloading. It's just a React component that's fetching the updated data and putting it dynamically into the same page that we're always working on. Then we can also try the delete scenario. And that happens if we go back into front end. That is happening directly into the catalog.js file. There is a section called delete item that's invoked by that red delete button. See, there's going to be a confirmation. Then it invokes the catalog API with the ID of the item, and then it performs the delete, and also it removes it from the client state. So to see that in action, let's go back to the client. And then I'll actually like to keep this bronze shield and the other items. So what I'll do is I'll create quickly another one. Let's just call it delete me description, and then I'll say price 4, right? So I'll save this item is created. And for the delete operation, all you have to do is click on delete. There's going to be a delete confirmation box here. Click OK, and the item is gone. And you can always confirm that these are actually happening in the server side by refreshing the browser, and you can see that the items are actually gone. And of course, you can also take a look at the database. Now, how about granting an item to a user, which touches bases with the inventory side? So to do that, what you can do is use this grant button over here. So let's say I'm going to grant this bronze shield to a user. So I'll click on grant, and this pops up this model dialog to grant an item. Now in this dialog, what I have done is I have made it so that anytime you open it, it's going to populate some random GUID for some random user ID. Remember, we don't have the concept of the users really here, so it's just a random user ID. So just like we did a random user in Postman, now this page is presenting a random user ID, random GUID here. And also there's a quantity that you can increase or decrease as needed. Now this here is happening back in the front end, is happening in the grant item form JS file over here. Here is where we can actually do a breakpoint for this one. This is where we will invoke the inventory items API with the data that we have about this item, and then the inventory service is going to take care of granting the item to the user. So if you go back to the browser and we say, let's say we're going to grant 2 of the potion, actually 2 of the grant to the bronze shield to the user, I'll say grant. And then if we go back here in grant item form, we can see that the inventory items URL is going to be invoked. This time is 5005/items. And that is going to use the user ID that we specified in the client side, the catalog item ID, which is right here, and the quantity, which is 2. And just to not lose it, I'm actually going to grab this user ID. I'm going to copy this one so that we can query for it later. And then, yeah, I'll hit continue. And that would have granted the item to the user. Now, there's no visual representation of that completion in this page, But that's why we have this other page for inventory. So let's go to the inventory section over here. And here is where you can paste that user ID and you can get inventory for the user. Now, all the logic here is happening. If you go back to the front end, this is happening actually in the inventory.js page. So this is the page that is going to allow us to populate items based on this on the entered user ID. That's going to go ahead and talk to inventory API with that user ID, and that brings back all the items that are in the user's inventory pack, which is rendered over here in this section, render items table. So we go back to the browser, we'll just hit get inventory, and there you go. The current inventory for the user is presented. In this case, just a bronze shield. Now, once again, it's also interesting to see what happens if there's an update, if an update happens to this item, right? Would the UI be able to reflect the fact that inventory needs to have updated data from the catalog when that happens? Would that take too much time? How would that render? So let's see. So we have bronze shield, it's named bronze shield, basic shield, quantity 2. So let's go back to the catalog, and we're going to edit the bronze shield, and we're going to change the name. So instead of having it as bronze shield, we'll just call it basic shield, right? And perhaps we'll also update the price. Let's say it's 9. And so now the bronze shield is named basic shield. So I'll hit save, and I'll go back to inventory, and I'll query again for the items of this user that we just granted inventory to. So I'll hit get inventory, and as you can see, the name has changed to basic shield. That means that as soon as we performed the update in the catalog microservice, that was immediately replicated via an asynchronous message into the inventory service, and inventory is now able to present the updated name of the shield, in this case basic shield. And that happened really fast. So there you go. We have gone through all the sections in this basic front-end user interface. So that marks the end of this module, and you have connected a modern single-page application built with React and hosted in Node.js with your two .NET-based microservices to light up a basic end-to-end scenario. And you learned all about CORS along the way. I hope you enjoyed building this system with me so far. In this module, you will learn all about the membership system built in to ASP.NET Core and how you can leverage it to stand up an identity microservice that can keep track of the different users that will interact with the Play Economy system. By the end of this module, you will have a solid understanding of the following. What is ASP.NET Core Identity and how you can enable it in your ASP.NET Core apps? An initial high-level view of the components to be added to our upcoming identity microservice. How to scaffold identity components into an ASP.NET Core app. How to integrate ASP.NET Core Identity and MongoDB. How to enable user registration and login in our identity microservice. And how to enable a REST API to manage the users stored in our identity database. Let's get started. In this lesson, we will learn about the need for a membership system to track the multiple aspects related to your microservices users, how ASP.NET Core Identity can help, and how to leverage it in our upcoming identity microservice. As you know, we have already introduced the concept of a user into the Play Economy system. Thanks to our inventory microservice, we can both grant catalog items and query for all the items in the user's inventory bag. However, at this point, we don't know much about this user other than the user ID. If we get on the shoes of our users or players for a moment, we will realize that there are a bunch of things that we would like to know or do in the system, but we are not able to do yet. For instance, as a player, to acquire catalog items into my inventory, I will need to pay for them first. However, I still don't know how much yield I have available or where this is stored. If my yield is stored somewhere in the Play Economy system, I would like to know how to access the system, and in fact, how do I become part of the system to start with? Then, as I register in the system, I'd like to know if my personal data is protected, especially things like my sign-in credentials. Is a combination of username and password enough to enter the system, or can additional layers of protection be put in place? Also, after I sign in into the system, what can I actually do there? Can I see or modify the inventory of other players? Can I happily grant 1 million yield to my own account to go and purchase items almost without limits? There should probably be some boundaries in there. As you may realize by now, we need a system to take care of all of this. Specifically, a membership system. Luckily, there is a membership system already baked into the .NET platform, and it's called ASP.NET Core Identity. This membership system brings in APIs to perform all the basic user management tasks, such as registering a new user, getting the list of registered users, and updating or deleting existing users. This includes APIs to send an email confirmation after the user registers and to perform the password recovery process. There are also APIs to sign in and sign out users and to manage the different roles you may want to enable in your application. For instance, in our system, you may want to separate our players, which can only perform a few limited actions, from our administrators, which can perform all sorts of management-related tasks across the whole system. A great feature of ASP.NET Core Identity is the fact that it includes pre-built UI functionality for user registration, login, logout, and personal data management. You can take advantage of these UI pieces as is, or you can also customize all or part of it as you see fit for your application. You can also enable more advanced features like multi-factor authentication, or perhaps you would prefer to delegate the authentication piece to external login providers like Facebook, Twitter, Microsoft, or Google. Finally, you can also store the additional claims and access tokens from these external authentication providers into ASP.NET Core Identity to offer more advanced identity-related scenarios within your app. Let's now see how ASP.NET Core Identity fits into our Play Economy system. To introduce all these identity-related capabilities to our system, we will stand up a brand new microservice called Identity. This microservice will be directly integrated with ASP.NET Core Identity to enable all the user and role management capabilities needed in our system. Let's take a quick look at the initial implementation of this new service. ASP.NET Core Identity includes a UI library based on the Razor Pages framework. We will take advantage of these UI components to enable user registration and sign in. That way, we don't have to invent the wheel around these basic UI scenarios. We will then implement a REST API for user management in a similar way to how we implemented REST APIs in our other microservices. That way, we can have operations to get the details of our users, to update details like the amount of yield assigned to a user, and also to enable user deletion. The good thing is that this time we don't have to implement a repository or any piece of code to interact with a database. ASP.NET Core Identity includes a series of classes called managers that allow you to easily interact with the different components of the membership system. For instance, you can use the user manager to perform all the usual CRUD operations involving our users, the role manager for all operations involving roles, and the sign-in manager to perform user sign-in, sign-out, and a few other operations. These identity managers interact with what we call identity stores, which are concrete data access implementations to interact with a specific data store provider. ASP.NET Core Identity comes with built-in stores based on the Entity Framework Core Object Relational Mapper, which by default is configured to store data in a SQL Server database. We could certainly use this default implementation, but since we are already using MongoDB as our database server in our previous microservices, we will use a MongoDB-based stores implementation instead. All the identity managers will be configured to use these MongoDB stores to persist users and roles to a new MongoDB database owned by the identity microservice, therefore avoiding the need to bring in SQL Server into the picture. Now, in terms of what actually needs to get implemented, we will use most of the built-in Razor Pages as is, but we will need to add a few modifications to the page used for user registration, just so that we can set an initial amount of yield for each new player. Implementing the user's REST API is also all on us, since that is not available by default in ASP.NET Core Identity. Although the actual implementation is very straightforward, since all the identity managers are already built in and they are generalized in such a way that the REST API does not need to know which is a specific configured identity store. Also, we won't need to implement the MongoDB stores, since there are multiple NuGet packages publicly available that can do this job for us. So we will just pick the one that works best for our needs and configure it in our microservice. Let's go ahead and create our identity microservice. It's time to spin up a new project for our identity microservice. Just like we did with our inventory microservice, we won't create the new project from scratch, but instead we will use the started project files I have attached to this lesson in the play.identity.start zip file, just under this video. Please download the zip file and extract it into a location in your box. So right here, I have already downloaded that zip file, is right here. So I am going to go ahead and right click and extract all the contents. Right here, I'll just say extract. And I have my new play.identity.start folder right here. So I'll go ahead and delete the zip file. And I'll rename play.identity.start into just play.identity. And this play.identity folder now becomes the location for our identity microservice. Okay, so I'll minimize this. And now here I am in a new instance of Visual Studio Code, where, by the way, I have hidden a few elements of Visual Studio Code just to give more clarity to the code that we're going to be working on. So at this point, we're going to go ahead and open that new folder that we just created. So I'll click on Open Folder right here. And then I'll go into the projects and I'll select my play.identity directory and I'll select folder. So this opens Visual Studio Code in the context of the play.identity folder. Right away, we're going to see that the C# extension wants to restore dependencies. So we'll say yes, restore. And now let me close this. And then what is the difference between this and the other microservices? Again, there's no difference. It's the same kind of starter template. The main difference here, of course, is that, we have a different namespace. This time it's going to be play.identity.service. But also in properties, under properties in launchstage.json, you're going to notice that we have, again, new ports. And you can see that the new ports are going to be 5003 for HTTPS and 5002 for HTTP. Okay, those are the ports that we have designed for this identity microservice. Now let me close this. And so what we want to do now is to, instead of coming up with any sort of UI for registration or login for our users, we're going to take advantage of the code generation capabilities of the .NET SDK, and we'll let the SDK generate that UI for us. We don't have to generate it manually. So in order to do that, the first thing that we have to do is to introduce a few NuGet packages. So let me go ahead and open up my terminal. So I'll do Ctrl-J and I'll go into terminal. Now perhaps I'll collapse this for a moment. And here we're going to add a few NuGet packages and a tool. The first thing that we're going to do is install a tool via the .NET tool command, .NET tool install. And we're going to do it globally, -G. And the name of the tool is .NET ASP.NET Code Generator. And then for this tool and the packages that we're going to install, it is very important that you use the correct version of the tool according to the SDK that you're going to be using. In our case, we're using .NET 7. And so let's make sure we specify that version over here. So we will say version 7.0.0 is the corresponding one for .NET 7. So I'll hit enter. And that went ahead and installed this tool globally so that I can use it in any project that I want in my machine. Okay, the next thing that we have to do is to install 4 NuGet packages that will enable code generation for the ASP.NET Core Identity UI. So to do that, I'll go into src, play.identity.service, and then let's install those packages. First package is going to be .NET add package, Microsoft.Visual Studio, .web, .code generation, .design. And again, let's make sure we use version 7.0.0. Hit enter. So that package is installed. Let me clean this. The next package is called, and I'll just try to reuse a little bit of this command line. It is called, so let me remove this, Microsoft.ASP.NET Core.Identity.UI. Say UI. Again, version 7.0.0. So I'll hit enter. Okay, let's clean this. Next package is called, again, let me reuse a little bit of this, Microsoft.Entity Framework Core.Design. Let's not get confused here. We're not going to be using Entity Framework or even SQL Server as part of this program here, but we do need this NuGet package and the next one so that we can generate the UI that we need to generate. After we generate that UI, we're going to remove these NuGet packages, right? So it's just a temporal thing to be able to do the code generation. So Microsoft.Entity Framework Core.Design. So I'll hit enter. And then clean this. And finally, we're going to be doing Microsoft.Entity Framework Core.SQL Server. All right, hit enter. So that is done. And if everything went properly, and if we do Control P, and if we go into our play.identity, by the way, I just did Ctrl+Shift+P, and then I can start typing to look for the name of a file. In this case, I'm looking for play.identity.service.csproc. What I want to show you is that now we have all those references added into the project, right? So they're showing up right here, and they're showing up also over here. All of that has been properly added. Okay, so let's close this, and then let me go back, Ctrl+J into my terminal. What we can do now is actually use the code generation to generate the files that we need. So to do that, we're going to do .NET ASP.NET Code Generator. And here you have to define what kind of code generation you want to execute. In our case, we want to generate files for identity. So we will just say identity. And then here the interesting thing is that you have two options. You can this framework can use all the files that are built into the .NET runtime and keep the files inside so you don't have to see them at all. Or you can ask it to pull out some of the files that you do want to modify so that they're combined with the files that are already built into the ASP.NET Core runtime. It's a nice capability that allows you to customize the files that you want to customize while keeping all the other files inside the framework and outside of your project. So in our case, since we do need to customize the logic for registration, we're going to ask the tool bring in the files for registration. So we're just going to say files, and then we will say account.register. So I'll hit enter, and this should go ahead and it's going to build our project, make sure that everything is built in properly, and then it will go ahead and perform the code generation. And that just completed. So let's now close this terminal and let's go back into our Explorer. Ctrl+Shift+E to go back to Explorer. And then let me expand this a little bit. And you're going to notice that there are a bunch of new directories and files in our structure. So right away, you can see that there's an areas section here, okay, where the important thing really is the pages that it has generated. And under account, you can see that now we have a page for registration. That's the one page that we took out of the ASP.NET Core binaries and into our own project so that we can modify them later. And we'll take a look at those files later. But for now, there are more files here than what we need. And some of those files are actually this data and this identity hosting startup. We don't need those at all for our project. So we're going to just right click and delete that. So data goes away and identity hosting startup also goes away. What else we have here? We also have a pages directory, which has some shared layout and imports as part of the Razor Pages framework. Use it, of course, some sort of layout to the page that you're going to see for login and for registration. But we're not going to be touching those really much across this course. The other thing is www.root, which adds some CSS on some JavaScript files, because these are Razor Pages. They need some sort of styles, right, to look pretty, basically. And lastly, there's this scaffolding readme.txt that just tells you that, the support for ASP.NET Core Identity, which is the framework we're going to be using for identity, has been added. Now, one thing that we can do also at this point is just go back into our project file, and we can remove the Entity Framework package references, because like I said, we don't need anything from Entity Framework really here. Moving on. And so we're just going to remove these two package references, Microsoft Entity Framework Core.Design and Microsoft Entity Framework Core.SQL Server. So I'm going to remove those two. We don't need them. We just stick with these three references for now. So now let's make sure, so I'll close this, and let's make sure everything is built in. So I'm just going to do Ctrl+Shift+V, my keyboard, and this should build successfully. Everything is building just fine, no errors. And at this point, we have a new identity microservice that is already integrated with a few basic ASP.NET Core identity building blocks, most of it generated by the .NET CLI and the ASP.NET Code Generator. In the next lesson, we will expand our ASP.NET Core identity integration by using MongoDB and its backend store, and we will enable both registering new users and letting them log into the system. By default, ASP.NET Core Identity uses Entity Framework Core and SQL Server as its backend store. However, since our existing microservices are already using MongoDB, it's not a bad idea to use the same database in our identity microservice. Let's see how to enable this. So here I am in Visual Studio Code once again, and I have opened my terminal into the play.identity.service directory. And what I'm going to do now is to add a couple of NuGet packages that we're going to need to enable the MongoDB integration. So let's add the first package, .NET add package ASP.NET Core .identity.mongodb core. This is the package that enables having a series of stores. It's called stores classes that can integrate with ASP.NET Core Identity to enable MongoDB as a backend store. It's a public open source project that you can find in the web. The next one is just going to be our play.common library. So .NET add package play.common. Okay. And as you know, we've been creating this library so far so that we can reuse a bunch of components from that one. And in this case, we're going to be using the service settings class that we have in that library to specify the name for our microservice and how to name the database that's going to be used in this microservice. Now that we have that, I'm going to close this terminal, and I'm going to now define the entity classes that are going to define the users and the roles in our identity microservice database. So to do that, the first thing is going to be add a new entities directory. So I'm going to right click and at the root here, new folder. It's going to be entities. And in this folder, I'm going to create a new file. It's going to be named applicationuser.cs. Let's give it a namespace. It's going to be play.identity.service.entities. Okay, so let's declare the class. So public class application user. And then this class has to inherit from the Mongo identity user class. That has to be of type. In this case, it's going to be GUID, because the ID of our users is going to be of type GUID. But to use this class, we have to import namespace from that NuGet package we installed a moment ago. So to do that, we can do control dot, and then we can import the ASP.NET Core Identity MongoDB Core Models namespace. Similarly, for the GUID class, we can do control dot, and then we can import the system namespace. So this application user represents a user in the system. And one customization that we're going to bring in here is the fact that we want to allow the user to specify how much GIL or how much money it has in his bag, so he can use it later to buy items from the catalog of items. So to do that, we're going to define a property here. It's going to be prop decimal GIL. So that's how much GIL the user counts with. And one more thing that we might want to do to this class is to specify what is going to be the name of the MongoDB collection that's going to be generated into the identity database. Just so that we don't end up with a collection named application users, but instead, for instance, we can give it the name of just users. So to do that, it is really just as easy as specifying an attribute here. So we can say collection name. And let's see if we're missing a namespace. Yes, let's use MongoDB generic repository.attributes. And the collection name we're going to give to this class is going to be users. That way, a users collection is going to be created into the database. Now, just like we did this, let's create another class to represent the roles, the user roles in the system. So right click on entities, new file. Let's name it application role.cs. Let's give it a namespace. Play.identity service entities. And then let's declare the class application role. And in this case, the class needs to inherit from Mongo identity role, again of type GUID. And again, we have to import the right namespaces. Let's do that. And that's pretty much going to be it for the class. We don't need to add a body in this case, but we want to still specify or decorate this class with the collection name attribute. So collection name, and I'm going to import again that namespace, just so that we can name the collection as just roles, as opposed to application role, which is what you would get if you didn't specify the roles attribute. Now keep in mind that you can keep extending both the roles class and the users class with as many properties as you need in your system. This is really up to you, and all of those are going to end up in the database. So for our purposes, this is really all we need at this point. And now that we have these two classes ready, it is time to make use of them where it makes sense. And the first place where we're going to use them is in pages, shared, and login partial.cs HTML. Now this file here is the Razor page for our login experience. And really the only thing that we want to do here is to make sure we stop using the identity user class here, which is built in as part of the ASP.NET Core Identity Framework. And we want to switch it to use our brand new application user class. So what I'm going to do is just select identity user. I'll do a Control H, and let's replace it with application user. Okay, so replace and replace. Okay, now for this to actually work, we also have to import the correct namespace, just like we do in our normal C# files. So I'll do using play.identity.service.entities. All right. So with this, login partial will make use of the correct application user class. Now let's close this one and let's go now into areas, account, and register.cs HTML. And I'm going to collapse this for a moment. And this file here is another file based on the Razor Pages framework that represents the C# code that is behind our registration experience. And if we scroll down here, you're going to see that this is a class named register model that inherits from page model, okay, which is the abstract class that represents a page in the Razor Pages model. And in this class, we're making use of a few objects here that we know as identity managers. So these are different objects that can be used to interact in one way or another with the ASP.NET Core Identity Framework. So we declared all those plus a few other helper objects here, and we are injecting instances for all of those in the register model constructor. Now, if you keep scrolling down, we'll see that we have a property here called input, right, of type input model, and this is the property that will have all the inputs that the user has entered in the registration page. And we're going to see this input model in a second down there. And then also we have a couple of output properties that we're not going to be touching right now. But if we keep going down, we're going to see that here is the actual input model. And the input model has our email, our password, and the confirmed password that user will enter in the registration page. Now here we also have a couple of methods like onGetAsync, which is used when this page is being retrieved back into the client, right, into the browser. And we also have onPostAsync, which is a method that is being invoked when the register page is sent into the server, right? Now, the first thing that we're going to do in this page is make sure that we also make use of this application user class. So let me scroll up. And as you can see, all of our identity managers currently are using the identity user class. So let's just make sure we change that. So I'll do Control H, and then replace again identity user with application user. And let's just do use this button here for replacing everything. So replace all right there. Okay. And we also need a namespace. So I'll select application user right here. I'll do control dot, and then I'll do using play.identity.service.entities. All right, and for some reason that didn't work. So let's just do the import manually this time. So I'm going to go up here and I'll say using play.identity.service.entities. And now we have that, we're going to go down into our onPostAsync method. And like I said, this is the method that's invoked when the page is sent back into the server, right, to perform the registration. And what we want to do is to modify this user here, this application user, so that it has the initial starting GIL that we're going to be assigning to every new user. All right. And so for that starting GIL, what we're going to do is first, let's actually go back to the top and let's declare a constant at the very top here. So over here, we'll declare private const decimal starting GIL, which is going to be, let's say 100, right? So every user will start with 100 GIL. So let's now go down into onPostAsync right here. And what we're going to do, like I said, just after creating this user object, we're going to add one more line and we will just say user.GIL equals starting GIL. That will make it so that when we reach this other line down here and the user is sent down into a ASP.NET Core identity, it will be created into the identity database using that GIL that we have specified. Okay, and that's really all we have to do in these Razor pages. And what we want to do now is go and add the required configuration into our app-settings.json file. So I'll do Ctrl+Shift+E to show my Explorer, and then I'll go down into our app-settings.json file, this one over here. And the first thing is going to be getting rid of these connection strings setting here that we don't need. That will be for Entity Framework, we don't need that. And then, just like we did with the other microservices, we're going to declare service settings. And here we have to declare the service name. So in this case, service name is going to be identity. The next thing is going to be our MongoDB settings so that we can tell how to connect to MongoDB. So MongoDB settings. And so we need a host, which again is just going to be localhost. And we need a port, which as usual is just 27017, the default port that the MongoDB uses. And now that we have that, it is time to go to startup to actually wire up all of these things to make sure that everything is constructed properly on boot. So I'll go to the startup file on the left side here. And perhaps this time we'll just collapse this again. Scroll down into our configure services method. And here we're going to do a few things. First, we need to configure MongoDB, the MongoDB driver, so that it serializes all of our GUIDs as strings. So this setting that we're going to specify here has already been configured if we were using MongoDB directly, as we've been doing in other microservices. But in this case, remember that we are using MongoDB as an integration point with ASP.NET Core Identity. So we don't talk directly to MongoDB ourselves. So there are some things that we may have to do a bit more manually than before, but it's not really a lot. So let's do Bison serializer that register serializer. And let's see if we need something to import. Yep, so using MongoDB.bison.serialization, register serializer, and then we'll do new GUID serializer, import missing namespace, and then we will do Bison type, control dot, using MongoDB.bison.string. So with that, all GUIDs are stored as strings in the database. The next thing that we're going to do is to capture the values of our service settings configuration and our MongoDB settings configurations that we just put in app-settings.json. So to do that, let's do var service settings equals, we'll use our configuration class as usual, get section, and it's going to be, the section has to be the name of service settings, which we may need to import here. Yep, using play.common.settings comes from our play.common NuGet package. And then we'll convert that via the get method. We convert that into a service settings instance. Okay, so that's how we can read service settings. And then let's also read our MongoDB settings. So MongoDB settings, same thing, but now the name is MongoDB settings. And now comes the most interesting part so far, because here's where we're going to wire up the ASP.NET Core identity pieces into our startup. So we're going to be using a method that sets off all the default configuration of ASP.NET Core identity for us, so that we don't have to really write a lot of code for this. So to do that, we can do services.add_default identity, and then you have to specify the type of your user, the entity, the user entity that we'll be using with our database and with ASP.NET Core identity. And as you know, that's going to be application user, for which we may need to import a namespace again. Yep, there it is, import namespace. So just by doing this, all the different UI components from ASP.NET Core identity will just work in our identity microservice. You'll see in a moment how that works, plus a few other things. But we need to do more. So we don't just have users, we also have to specify roles. So for our roles, we'll say that add roles, and here's where we're going to specify application role. And next is where we have to actually configure ASP.NET Core identity to use MongoDB. So to do that, what we're going to do is just say add MongoDB stores, and then we specify our user class, application user, and our role class, application role, and then the type that we're using for the identity of our users, which is GUID. Okay, let's open a constructor here. And here we have to specify two parameters, which are going to be the connection string to MongoDB and the name of the database. So for the connection string, we can say now MongoDB settings dot connection string, and for the database we can say service settings dot service name. Okay, so with these few lines, we have configured ASP.NET Core identity and we have connected it to our MongoDB database. Now there are a couple of more pieces of configuration to do here in order to make this work properly. Since we are not now bringing UI components into what was otherwise just a web API project, we need to add a few lines in the configure method. So let's scroll down into configure, and let's add a line somewhere around here saying app.use static files. So this is so that all those static files that we saw a moment ago in the Explorer can be used in this application. And also we have to go here and in the use endpoints call here, we have to configure endpoints to also be able to use Razor pages. So endpoints.map Razor pages. And this is because a web API project normally has nothing to do with Razor pages, but in our case, we are extending it a little bit so that we can show the Razor pages that come from ASP.NET Core identity. So now we are almost ready to see our service running in action. But one thing that we should verify before doing that is to make sure that we have our Docker containers up and running, specifically the container for MongoDB, of course. So to do that, I'm going to open up my terminal here by doing Ctrl-J. And I'm just going to do docker ps to see if I have any container running right now. So from this, I can tell that there's no containers running. So I'm missing my MongoDB container. So to get that up and running, what I'm going to do is to go back to my play.infra directory. So let me go back up into projects, and now I'll go into play.infra, and here's where we have our Docker Compose file. So to start our infrastructure services, I just have to do docker compose up, and then -d for the dash mode. And that's going to go ahead and start our containers, both MongoDB and RabbitMQ in this case. So now that I did that, let me go back to where we were. So play that identity, src, identity service, and then I'll just do .NET run, and that's going to start up our identity microservice for the first time. So there it is, up and running. And now we can go ahead and try to register a user in the system. So to do that, let me actually open a browser this time. And we know that our service is living in localhost 5003. And the registration page is actually in this location, identity, account, register. So if you go to that location, you're going to see this page, which is provided by the ASP.NET Core Identity built-in UI components. So now that you're here, you can go ahead and create a user. So for instance, I'm just going to create really a fake user with some fake email like player1@play.com. And then I'll type a password. And then before we actually create this user, notice that there's built-in validation in this page already. So for instance, if I don't use a proper email, like something like this validation is going to kick in right away, right? And if my passwords perhaps don't match, that's going to also kick in some validation. So this page by itself is already very useful for our registration purposes. So I'll go ahead and click register. And the user should have been registered by now. And of course, we're seeing this kind of unexpected page, but this is because we are not really in a location where we can display a home page, right? This is not really a web portal. We just happen to be navigating into the registration page to create a user because it is convenient, but we don't have a portal by any means right now where users can go in and have a home page and then navigate. But the user should have been created. So let's take a look at VS Code. Let's take a look at the database and see how that's looking. So I'm going to collapse this terminal, and I'm going to bring in via Ctrl-Shift-P, I'm going to bring in the activity bar on the left side, and then I'm going to show via this ... our MongoDB database. So I'll minimize this and that, expand this. And notice that now, next to our catalog and inventory databases, we also have an identity database now. And that database now has a users collection, and that collection has one document, which is going to be our user. As you can see, player1@play.com, and you're going to see that it has a bunch of other attributes that are coming in by default from ASP.NET Core Identity and the MongoDB integration that we have enabled. But also notice that at the very end, our property is also included. So this user has a default amount of 100 GIL already defined for himself. And now that we have this user could potentially also log in into the system. So if you go back to the page, let me go back to, still back. We're back in the registration page, but we can also now click on login over here, login. And here's where the user could just log in. So I'll do player1@play.com, the password, and then I'll do login, and the user would have logged in. Of course, we can't verify this by any means right now, because like I said, there's no home page, but the login functionality is in place. Okay, I'll close this. And so at this point, we have a way to register and log in our users, and we have a database populated with users right now. So in the next lesson, we are going to add a proper REST API to manage users so that other components in the system can actually interact with our users database. So far, we can register and sign in users into our identity microservice via the ASP.NET Core Identity default UI pages. However, we should also provide a REST API that other parts of our Play Economy system can later use to interact with our users database. So let's add a users REST API. I'll start by going to the root of our play.identity.service directory. So I'll just right click and I'll add a new file that we're going to call dtos.cs. And in this one, let's add the right namespace. So it's going to be play.identity.service.dtos. We're going to define two DTOs here. The DTO to retrieve or to get users from the database, and the DTO to update the information about a user. We are not going to define a DTO to create a user into the database because that is already covered by user registration in the UI page for registration. So let's define our first DTO. It's going to be public record user DTO. It's going to have an ID, and let's import a missing namespace using system, a username, and email, the amount of GIL assigned to the user, and a created date, the date that when the user was created. Okay, so that's the DTO used to return users in our GET REST APIs. Next, let's define public record update user DTO. So this is going to have just an email and the amount of GIL. So these are the only two things that we're going to allow updating in the user, their email and the amount of GIL. Nothing else is going to be modified. But now, since this is a DTO for performing updates, we probably want to have a little bit of validations right away before accepting values via this DTO. So we're going to, for the email, of course, we're going to say that this is required, and let's import our system component model data annotations namespace. And since it's actually an email, we can also actually take advantage of the validator for email addresses. So here we can say email address, and that will make sure that whichever value comes in there, it has to be an email address. No other kind of a string is going to be allowed. And then for the GIL, we're going to say that there's going to be an allowed range of values. So we're going to say range. And that range is going to go from 0 to, let's say, 1 million. So 1 million is the maximum amount of GIL that can be assigned to any of our users. Okay, so that covers the two DTOs that we're going to be using. And just like we have done in other microservices, we're going to create also an extensions class that can map from our application user entity into our user DTO for the purpose of using them in our GET REST API operations. So I'm going to right click over here, play identity service again, right click, new file, and let's name it extensions.cs, and let's give it a namespace. It's going to be play.identity.service, and let's define the class static class extensions, and the method is going to be public static user DTO. Remember that all extension methods should live in a static class and they should be static. So the method is going to return a user DTO, and let's call it as DTO. We may need to import, let's import a missing namespace. And this is going to be extending our application user class. Let's name it user. And let's import a missing namespace again. And let's open and close braces. So remember, we use extension methods here so that anytime we have an application user, we can easily transform it into a user DTO, specifically for the purposes of returning this user in our REST API. So for that transformation, we can just do return new user DTO. Now we will say user.id, user.username, user.email, user.gil, and user.createdOn. And again, perhaps I'll do multiple lines so that we can see better what's going on here. There. So that's all we have to do for the extension method. So now for the actual interesting part, which is the creation of this user controller. So let's go to our controllers folder where we have nothing right now. And I'll right click, I'll say new file, and let's name it users controller.cs. And at this point, I'll go ahead and just collapse this pane here so we have more space to see. Let's declare a namespace. So namespace play.identity .service.controllers. Let's declare our class, public class users controller, which has to inherit, as we know by now, from controller base, which makes it an API controller. And also it has to be decorated with the API controller attribute so that we get some built-in by default behaviors, nice behaviors for validations specifically, and a few other behaviors for error checking. And also let's find a route, a default route for this controller. And that route is going to be just users. And so the way that we're going to interact with our users database is not by talking directly to that database via the MongoDB driver, but instead we're going to be using the user manager, which is the class that ASP.NET Core Identity provides us so that we can interact with users without having to know what database has been configured in the backend. So let's go ahead and declare a private variable to hold on an instance of this user manager. So private read-only user manager of type application user manager. So let's import missing namespaces there and here. And then let's define a constructor for this class so we can receive that instance. So public users controller user manager of type application user manager. So as you can see, we are doing dependency injection of an instance of the user manager that's going to be provided by ASP.NET Core Identity, and we're just going to assign that to our local user manager instance. So now we can start defining our actual REST API. And as usual, we'll get started with the get method. So let's define the get method that we can use to retrieve all the users in the database. So let's scroll down a little bit here. And let's define public action result of type IEnumerable of type user DTO get. So just get like that. And so let's make sure we import the right namespaces. And this is user DTO there. And let's add the correct attribute for the verb. So this is going to be an HTTP GET. Okay, let's go down a little bit. And so to retrieve the users from the database, we can use the user manager in a very straightforward way. So we can do var users equals user manager dot users, and then I'll do to list. Let's import system.link for this call, and then we'll do the transformation into our DTOs. So I'll do select user, transform that user into a DTO via our asDTO extension method. Yep. So with that, we have our users, and then we can just say return an OK result with users. Okay, so that's all we have to do for the users get operation. Let's now implement an operation to retrieve information of one specific user. So in that case, we're going to define public async task of action result of user DTO get by ID async. It's going to be the name. It's going to receive a GUID ID. Okay. Again, let's import missing namespaces. We need tasks. And I think we need system here. Yep, using system. And let's also decorate this with the right verb, which again is HTTP GET. But we're also going to be needing to define a template for this method because we have to receive an ID here in order to identify the user we're going to return. So in this case, we need to receive an ID in the route. So the end of the route has to be ID. So basically something like /users and then /123. So some ID, right? That's going to be the ID. And so let's go ahead into the body. And again, to implement this, we can make use of the user manager. So we'll say var user equals await user manager that find by ID async. And then we'll do just ID, but this expects a string. So we will do toString. Going down. And so two things can happen here. Either we find the user and we can return it, or we don't find it, and that's going to be just a null value. So let's first check for that null value. So if user is null, we will just say not found. Return not found. Can't find the user. Otherwise, we can return user converted as DTO via our as DTO extension method. Okay, so that's it for the get operations. Now let's work on our update operation. So the one that we can use to modify an existing user. So this is going to be, again, public async task of action result put async. This one has to receive the ID of the user to be modified and our update user DTO, which contains the payload of the modified user. Let's decorate this properly with the HTTP put verb and the template for also ID. So same route as we got over here. Users 123 is the route that you will be using for the put, right? But in this case with a body. So in order to do an update operation, the first thing that we have to do is, of course, try to find the user. And so to do that, that's going to be actually very similar to what we did for get. So I'm just going to do the same first few lines as in get. I'm going to copy that over here. So that way we can find the user. If we cannot find it, not found, no issues there. And then if we can find it, it's time to update the details. So in this case, we want to update user.email. It's going to be userdto.email. But then we have a convention here already established by ASP.NET Core Identity where the username of the user is exactly the same as the email. So we will follow that convention. So we will say that user.username is userdto.email. So that's how users are created when you register them, same username as email. So we will just follow that for an update. And finally, user.jill equals userdto.jill. Then we'll go ahead and say await user manager that update async user. And finally, as with any put method, we can just say return no content. So that's the update operation. And now let's go ahead and do the delete operation. Okay, so for this one, let's declare public async task action result delete async, and we are going to receive only the GUID this time. So GUID ID. Scroll down. Again, let's decorate this with the right verb, HTTP delete. And the template again is going to be the ID. So just like before, we said we're going to have a route like /users/123, just like that here, just for reference. And just like before, we can find that user first. So again, same 3 lines. Can do that here. Find the user. If we don't find it, it is a not found user, of course. But if we can find it, then we will say await user manager dot delete async. We send the user, and then we can return no content. Okay, so with that we have our REST API all ready to go. So it is time to try it out. So I'm going to go ahead and do Ctrl+J to open my terminal, and I'm just going to do .NET run in the play.identity.service directory. So .NET run starts web server. And now what I'd like to do is to grab the swagger.json OpenAPI specification to import it into Postman. So to do that, I'll open a browser. And then I'll go to localhost 5003, and then I'll go to Swagger, which is built in into any .NET 5 project, ASP.NET Core project. And you can see we have our REST API ready to go there, but we're not going to be playing with it over here. We are actually going to be clicking on Swagger v1 swagger.json, and we're going to copy this URL. Now let's open up Postman. And here, as you remember, we do have our collections for the catalog and the inventory microservice. So it is time to import the one for our users REST API in the identity microservice. So I'll just click on import, and I'll click on link. I'll paste our swagger.json file here, the URL, continue, and then I'll just say import. Okay, and so with that, we can start trying out all these APIs. So let's go to play.identity.service. We have our users section here, and then let's try get users. But of course, before doing that, we have to modify over here the play identity service collection. We'll click on ... we'll do edit, and we'll go to variables. Okay, let me close this section here. So here, remember, we have to specify the base URL that Postman is going to be using when calling the methods in this REST API. So in this case, we know that the URL is going to be https localhost 5003. We'll do that for initial value and for current value. Okay, so I'll close that. I'll save changes. And now we can go to our get users API, where base URL is https localhost 5003. And I'll just hit send. And as you can see down here, we have our one user is being returned. So the integration with ASP.NET Core and MongoDB seems to be working just fine for the REST API. Let's also test our other methods. For instance, let's try to get a user by ID. So let's grab this ID. I'll do the get users by ID method here. I'll just paste the ID right there, hit send, and yep, that is working properly. Let's also try our put operation, in which we're going to paste ID once again, but now we have to specify a body, right? So let's grab the details, the current details from the user, like the email and GIL, from this tab to this tab. And what we're going to do, we're not going to change the email, but perhaps we can change the amount of GIL. So let's say that instead of 100, he can have 200 GIL at this point. And with that, let's hit send. We got 204 no content, which is expected. And if we do a get again for this user, send, we can tell that yes, the GIL was updated to 200. And finally, we can go ahead and test the delete API. Let me just copy the user ID once again. Delete API. We'll paste the user ID right there, and we'll hit send. At this point, the user should not exist anymore. If we try to do a get for that user, let's see what happens. Yeah, photo 4 not found. The user has been removed. So yeah, it seems to be working just fine. And with that, our integration with ASP.NET Core Identity is mostly complete. That's the end of this model, and in the next model, we will learn about the multiple patterns and techniques that you can use today to secure your microservices. In this module, you will learn about the modern approach to microservices security, the tools and techniques you can use today to protect your microservices, and how to properly integrate them into our identity microservice. By the end of this module, you will have a solid understanding of the following: why a microservices-based system needs authentication, what is and how token-based security works, what is OAuth 2 and the participants and steps of the authorization code flow, what is OpenID Connect and how it complements OAuth 2, what is Identity Server and how it relates to OAuth 2 and OpenID Connect, and how to turn our existing identity microservice into an authorization server. Let's get started. In this lesson, you will learn about the need to introduce identity-related components to your microservices-based application, the dangers of not doing this correctly, and the modern approach to securing your services. Let's go once again through one of the scenarios enabled up to this point. John, one of our players, would like to see the items in his inventory back. He would request his inventory via his preferred client, and this one in turn would send a GET request to the inventory microservice, asking for all items associated to the specified user ID. Normally, the inventory microservice would just return the items. However, our service should probably start asking a few questions before handing them over. For instance, inventory may want to ask, "Who are you?" or "Are you allowed to talk to me?" Since it should probably not just hand over its precious data to anybody that asks for it. But even if the request is allowed to come in, another important question arises. Do you have access to John's inventory back? Think about it. Inventory doesn't really know that the caller is John. It could be any other player trying to retrieve John's inventory, which by all means should not be allowed. Only if our microservice can answer these questions and can confirm that the caller has access to the items, it would query them from its database and return them. In summary, we need to establish the identity of the caller. The good thing is that we do have an identity microservice by now, so we should be able to enable authentication in our system. That is, we should be able to confirm that the caller is allowed to retrieve the items for the specified user. For instance, the client could be modified to present a sign-in screen to collect the email and password of the user, and then send them in the request to the inventory microservice. Inventory would then ask identity to confirm the credentials are valid, and probably also ask to return additional info about the user, like its user ID, to correlate with inventory database. If all looks correct, inventory would be ready to return the data to the caller. We would also update our other microservices like Catalog to receive the credentials and do the corresponding checks with identity. The problem with this approach is that we will be sending the user's credentials on every single request to each of our microservices, which presents a few concerns. If SSL is not enabled, which of course should not be the case, an attacker with a package sniffer could easily grab the credentials. Even if SSL is enabled, tools like Fiddler, capable of decrypting the URLs, could have been installed in the user's machine, assuming the user provided consent for it. The URLs would likely get logged on each microservice, and the logs might not be secured properly. The size of each request will be bigger than it needs to be, and there are limits to request URLs. The client would need to ask for credentials every time, or perhaps would keep them in its local cache, which is just as bad. And let's not forget that we might overwhelm our identity microservice with potentially hundreds of checks on every request from each of our microservices, which will of course also slow down the overall system unnecessarily. There's probably a better way to authenticate our users. As a side note, I just wanted to call out a bad practice of some websites that you might be familiar with. Have you ever tried using one of these sites that asks you for your bank account credentials so it can help you manage your finances? Think about what these websites are doing. They would even assure you that your data is very safe since your login username and passwords are stored securely in a separate database using multi-layer hardware and software encryption. Even with their best intentions, this is definitely a bad idea because nobody other than your bank who owns your credentials should have a copy of them. You really don't know what this third party is planning to do with your credentials, how safely it is storing them, and also what exactly you're allowing them to do with your bank account. Presumably, this is read-only access to your account, but how can you be sure? We won't be dealing with external websites in this course, but the appropriate authentication and authorization patterns you will learn next still apply for any scenarios like this. What is then the right way for our client to request access to John's inventory bag? The ideal and modern approach is called token-based security, and it works like this. When John wants to get his inventory back, the client first requests authorization from an authorization server, which in our case would be our identity microservice. It is this microservice, not the client, that will then present John with the sign-in form where he will enter his username and password. Once John submits this form, his credentials will be sent to the identity microservice, not to the inventory microservice for validation. Once identity has verified the credentials, it generates a signed authorization token and sends it back to the client. The client can then use this authorization token to try to access John's inventory bag in the inventory microservice. If inventory can verify that this token presents the required authorization, it will go ahead and return the items to the client. Notice that with token-based security, the credentials are sent only once from the form presented by the authorization server and not on every subsequent request. There is more going on here before generating the token, but we will look into these details in the next lesson. The generated token represents consent from the user, and it includes information about how to verify the token, since it includes details about how it was signed, where it came from, since only tokens generated by our authorization server should be allowed, where it can be used, because it should be valid for use only by our microservices, who is authorized by the token, since it can include many details about John in this case, including his authorization roles, what can be done with the token, because a token may grant access only to some microservices, or even to specific actions within a microservice, and much more. Now the question is, how to generate this token and how to do it in a standard way so that we follow all the best security practices while not having to spend a lot of time writing code to get things right? Luckily, there are already well-known protocols and standards that we can use for this. In the next lesson, we will learn about OAuth 2, the de facto standard for authorization these days. In this lesson, we will learn about the OAuth 2 protocol, how it works, and why it should become the basis of your microservices security strategy. Let's start with the standard definition of OAuth 2. OAuth 2 is the industry standard protocol for authorization, allowing a website or application to access resources hosted by other web apps on behalf of a user. In essence, it is a security standard where you give one application permission to access your data in another application. The framework that describes OAuth 2 was released in 2012, and as of today, has been adopted by dozens of service providers of all sizes. Let's see how it works. There are multiple authorization flows supported by OAuth 2, but here we will focus only in the recommended flow for single-page applications or SPAs and native clients, which are the ones our microservices will integrate with during this course. Let's first understand which are the participants in an OAuth 2 authorization flow. The resource owner is the person or entity that owns a resource, like John in our case, who owns his inventory bag. The resource server is the server or service that hosts the protected resources owned by the resource owner. An example here is our inventory microservice, which owns the database that contains the inventory items. The client is the application that wants access to perform actions on protected resources on behalf of the resource owner. This would be our game client, our web front end, and even the Postman app when doing local testing. And the authorization server is the server capable of authorizing the client to get access to the protected resources after authenticating the resource owner. This is our identity microservice. The flow starts when the resource owner uses the client to initiate an authorization request to perform some action, for instance, to retrieve John's inventory back. The client generates a code verifier, which is a hard-to-guess value that will be used later in the flow. The client then generates a code challenge, which is an encoded hash value derived from the code verifier, and sends it as part of the authorization request to the authorization server. The authorization server presents a sign-in page where the resource owner can authenticate. After authentication, the authorization server might optionally also present an additional page where the resource owner can provide explicit consent to which actions can be performed on the resources he owns. After this, the authorization server stores the code challenge for future verification and generates an authorization code which it sends back to the client. This authorization code is valid only for a short amount of time, ideally no more than 10 minutes, and is only good for one use. The client can then use the received authorization code plus the code verifier it had created at the start of the flow to request an authorization token. The authorization server verifies this request by generating the code challenge itself out of the received code verifier and comparing it with the code challenge it had already stored. If this doesn't match, then the request likely comes from a malicious application and an error is returned to the client. If all looks good, the authorization server verifies the received authorization code and generates an access token. The client can now use this access token to send a request to the resource server so it can perform the desired action on the protected resources. The resource server validates the received access token, and if all looks good, it executes the requested action and returns the corresponding response. This whole flow is known as the authorization code flow with PKCE, where PKCE means proof key for code exchange. This flow is ideal for public clients like single-page applications or SPAs and native or mobile applications, because there is no need to store a static, hard-coded secret in the client, which could easily be stolen. With no secret, the client can't get an access token right away. It needs to first acquire a valid authorization code only available after the user authenticates and provides consent. And even if a malicious application steals the authorization code, it would not be able to acquire the code verifier, which is dynamic and is only known to our own app. Let's take a closer look at the elements involved in the initial authorization request sent by the client. This is how an authorization request for the authorization code with PKCE flow looks like. Let's understand what each piece means. This is the address of the authorization server, which in this example is running in our local box. This is the endpoint in the authorization server that can be used to request an authorization code. There are many other standard endpoints available in the authorization server, as we'll see in a future lesson. By specifying code in the response type, we are asking the authorization server to respond with an authorization code, assuming successful authentication by the resource owner. The client ID is the unique identifier of the client, which was provided to the authorization server when the client was registered. Scope represents the resource or set of resources and the actions on these resources that the client would like access to. In this example, the client is asking for access to the inventory microservice REST API. The scope could be more granular if you wanted to allow only for read access, read-write access, or perhaps a more custom scope if needed. Redirect URI is the address where the authorization server will redirect the user after successful authentication. Just like the client ID, this URI should have been provided to the authorization server when the client was registered, which prevents phishing attacks. The code challenge is the encoded value derived from the hashed code verifier that the authorization server will store for future verification. And finally, the code challenge method is the method used to hash the code verifier to turn it into the code challenge. Let's now inspect the elements of the access token request, which the client sends to the authorization server after acquiring the authorization code. Again, this is the address of the authorization server, our local box in this example. This is the endpoint in the authorization server that can be used to request an access token. By specifying authorization code in the grant type, we are asking the authorization server to exchange the provided authorization code with an access token that the client can later use to talk to any of our microservices. As mentioned before, client ID is the unique identifier of the client, which was provided to the authorization server when the client was registered. Again, redirect URI is the address where the authorization server will redirect the user after successful authentication. It must match exactly the value used when requesting the authorization code. Code is the authorization code provided by the authorization server via the authorization request. And code verifier is the original code verifier that the client generated before computing and sending the code challenge as part of the authorization request. I think it's good to know the elements of both the authorization request and the access token request, since they help understand the different pieces involved in the OAuth 2 protocol. In the next lesson, we will learn about another important component of the microservices security landscape, called OpenID Connect. In this lesson, we will learn about OpenID Connect, its mechanics, and how it complements the OAuth 2 protocol. What is OpenID Connect? Don't worry, it is not an entire new security protocol to learn. OpenID Connect is just a simple identity layer on top of the OAuth 2 protocol that allows clients to verify the identity of the end user. Notice the emphasis on verify the identity. Identity is the one piece that OAuth 2 misses because, think about it, OAuth 2 allows an application to get access to resources on behalf of a user, but the client application never really knows who is that user that provided authorization. Let's understand why this is so important. Let's look at our simplified OAuth 2 flow once again. Just as before, John uses the client application to request authorization to retrieve his inventory back, owned by the inventory microservice. The identity microservice receives this request, authenticates John via the sign-in form, and, after the usual OAuth 2 protocol exchanges we learned about in the previous lesson, it sends back an access token to John's client. Now, imagine that John doesn't use this token in his client app, but instead he shares it with Jane by just pasting it in an email or an instant message. Jane then somehow provides this token to her own copy of the client app and then uses it to request John's inventory back. The inventory microservice will find no issues with the token, so it will gladly return the items in John's inventory to Jane's client. Everything looks good from the point of view of our microservices, but the client app was able to get access to protected resources when it shouldn't. This is because access tokens are not meant for the client app, but only for the protected resources. The client app can't even understand the access tokens. It needs a way to verify that access to the resources was granted to whoever is making use of the app. Let's see how OpenID Connect can help with this problem. Since OpenID Connect is based on OAuth 2, the involved participants are mostly the same, but they receive slightly different names. The end user is the person, and in this case an actual human, that needs to get authenticated. The relying party is the client application that outsources end user authentication to an OpenID provider. The OpenID provider is the server capable of authenticating the end user and provide claims to a relying party about the user. The flow starts the same way as with the OAuth 2 flow, but a key difference is that in the authentication request, a very specific scope called OpenID is required. This is really the only thing that signals to the OpenID provider that the relying party needs authentication. Other optional standard scopes could also be used here to retrieve additional claims about the end user. Upon receiving this request, the OpenID provider redirects the end user to the sign-in page as usual, optionally asks for consent to specific permissions, and then returns an authorization code. And just as before, the relying party then uses the authorization code to request tokens from the OpenID provider. Another big difference here is that the OpenID provider returns not one, but at least two tokens, the access token and the ID token. This additional ID token is what the relying party can then use to verify the identity of the authenticated user. It contains one or more claims about the end user, depending on the requested scopes. A key claim here is the subclaim, which provides the unique identifier of the user. After this, the relying party could either request more information about the end user via the OpenID provider userinfo endpoint, or it can just use the access token to make requests to any of the resource servers, like inventory in this example. Like I mentioned before, the main benefit of using OpenID Connect on top of OAuth 2 is the fact that the client can now verify the identity of the end user. But there are several other benefits of using this protocol. Scopes in OAuth 2 are very loose, so each service has to define them according to their needs. In OpenID Connect, there is a standard set of scopes you can use to request additional claims about the user, like profile, email, address, and phone. There are several standard claims that the OpenID provider can return upon request, like the required subclaim, which provides the unique identifier of the user, but also many other claims like given name, nickname, email, birth date, and many others. The userinfo endpoint is a standard endpoint in the OpenID provider that can be used to retrieve more information about the end user that might not be available as part of the ID token. More than a specific OpenID Connect offering, single sign-on is a side benefit since a single OpenID provider can be used to authenticate end users coming from different apps, and in most cases, the user will be required to perform the authentication only the first time. This happens, for instance, when after authenticating in Gmail, you're automatically authenticated to YouTube, AdSense, Google Analytics, and other Google apps. OpenID providers define a well-known endpoint that apps can use to discover the several other endpoints and features they can use as part of the user authentication flow. We will explore this endpoint in detail in a future lesson. OpenID providers can get certified by the OpenID Foundation via a standard suite of tests and requirements. There are dozens of certified OpenID providers you can choose from today, giving you lots of flexibility to use the one that better suits the needs of your apps. In the next lesson, we will learn about Identity Server, the OpenID Connect provider we will use through this course.